Hello guys, in this video I'm going to show you how to solve right view of binary tree problem. Right view of binary tree. Right, so given a binary tree, return an array containing nodes in its right view. Right view of binary tree is a set of nodes visible when the tree is seen from the right side. Right? So let's take a look at this example. We have a binary tree. Right? We have three levels. If it's standing on this side, on the right side, and look at the tree, I will see 1, 3, and 7. Right? As simple as that. The right view of this tree will be 1, 3, and 7. And how to solve this problem? Right? One observation is 1, 3, and 7 is just the last node of each level. Right? And if we can process one level, then we can you can if you can traverse level by level, then the getting the last node is not difficult. All right. So let's get into coding. So for level by level, as always, I'm gonna use a queue, right? I'm gonna use a queue to um, queue to store nodes. Let's say to go level by level, right? And I'm gonna use a loop, right? And loop, and this with this loop, I'm gonna process one level in one iteration, right? And then I also need uh, to push new node to the queue. And very important thing is that we need to determine if we are at the last positions of one level. Check if we are at last of one level, right? If yes, then we push to the result. Okay, let's get into it. Let's go one by one. I need a queue. Queue in JavaScript is just an array, right? And initially we have the root in the queue so that we have something to process for the first loop, right? As I said here, I want to process one level in one iterations here inside here. So the reason for us to get into this iteration is that we have something in the queue, which means the size of the queue is greater than 0. So at the beginning of each iterations, we need to somehow remember how many nodes are there in the queue currently, right? Because inside here, I want to add more nodes to the queue, right? So we need to remember how many nodes in the current level at the beginning here. so that we only process that exact amount of nodes, right? So let's call it level size is the queue size. So I'm gonna use another loop, right? I'm gonna process one by one until the level size is greater than 0, right? And here, actually, let's make it clear by for one iterations. I'm gonna reduce the size, reduce the level size by 1, right? So by this loop, I will process exactly this amount of node, right? So here, I'm gonna push new node to the queue. New node here is actually the node of the next level, right? It would be so the new node here will be the child node of the node that is out. I need to take out one node first from the queue. Here is 70 queue. Alright, I'm gonna loop through the left child and right child. Right, and I'm just gonna I only push to the queue when the child is not known, right? Only the child is not known, we push to the queue. Otherwise, I'll just skip it. Child, right? And the last thing that we need to do here is check if we are at last of one level. So, do you know when we're at last? It is when the level size equal to 0, right? Let's, for example, if we are at level 2, for example, right? So initially the queue has two node 2 and 3, which is all not in the level 2 here. So at that time we remember the level size is 2, right? So we're gonna process as long as the level size is greater than 0, right? So for the first iterations, we're gonna take out 2, right? We first for first iterations we reduce the level size by 1, right? So it 1 now, we take 2 out. Here the child of 2 is 4 and 5, we push 4 and 5 in, right? So now we're done with node 2. We dequeue the next node, right? Which is 3 out, right? And the level size now is 0, right? And it is when level size 0. It is when level size 0. We are at the last node of one level. Right? Same here, 3 had 2 child, 6 and 7. Okay. So after process 3, we done with 3 we have all node of the next level here in the queue. So we start processing the uh, next level, right? So check if we are last of one level just by check if the level size is 0 now. Then if it is a case, I'm gonna push it in the result, but we don't have the result array yet. Result is just an empty array. If level size is 0, push it to the uh, we push the current node, right? But here I'm gonna push the value instead, because in the test file we're expecting that the result array will be an array of values, right? So I think that is it. Let's run a test. Whoops. We is anything wrong here? We forgot to return the result array. Okay, it works. So that is it for review of a binary trees. Thanks for watching. See you in the next video.